ना पर ये कलम भी ढीठ तो कैसे रुकूं, फाड़ दूं कागज तो तेज दिमाग ये लिखूं ना सीधा मैं आके बकूं, मैं ये माइक पे साइड में रखी ये काम तो वाइब में सोता मैं कैसे थकूं, सीधे है काम ये सीधी है बात और सीधी है पीठ तो कैसे झुकूं, मुझे आता नहीं मेरा नाता नहीं, नेगेटिविटी से दूर हूं बैठा कहीं सच रहता जब आप ने झूठ का साथ, मैं तेरे इलाके का नेता नहीं, यहाँ करे सब अपनी तो क्यों चलूं पीछे मैं, दुनिया तो ऐसे ही घूरेगी, सोचते घर वाले कमा लूं पैसा पर करने तो सपने हैं पूरे भी, करना तो है ही मैं करके रहूंगा, मैं करता था क्या मुझको ध्यान नहीं, सोने की आदत और आलस का आशिक अब थानों से पत्थर बस पास नहीं, रहना पहाड़ों में कुछ और दिन फिर जाना है बादल के पार, मुझे साथ रहेंगे सारे ब्रो मेरे याद रहे साल 4 मुझे, कसर न छोड़ेंगे हसल में बजर न दबेगा पजल में, बोएंगे बीज हम ऐसे ये असर भी दिखेगा फसल में, कसर न छोड़ेंगे हसल में बजर न दबेगा पजल में, बोएंगे बीज हम ऐसे ये असर भी दिखेगा, कभी सोचता रोकता कभी मैं खुद को तो पहुंचता कैसे मैं यहाँ तक किया, रोज का लिखना इतना केगा हूँ सब तो मिट ना पाए शब्द, लिखूं ऐसा अब सुनूं मैं साल बाद तो क्रिंज ना आएगी खुद ही से, रखूं गर्दन ये ऊंची मैं हेल्प प्राउड मुझे नाज है आज भी खुद ही पे खुद ही से किया है, सारे यहाँ कौन था पीछे में भोंकता रोंगटे खड़े हैं, आज भी देते सलाहे हैं मुझे ये पता नहीं चाहते या मुझसे सड़े हैं क्यों सुनूं और किसी की मैं मौत खुशी की लूं, क्या पता मर जाऊं कल ही, पर मेरी माँ की दुआओं से चलती है सांसें तो खौफ ना मौत का पल भी।
Hello everyone, welcome. That was Army on the mic. Thanks a lot to Army for letting us use his music. Welcome everyone to today's stream of Walking Demon. It's our second stream, and today we'll be looking into getting started with quantum computing. Hope we can learn something new and maybe be able to pursue it in the coming future. I hope everything is all right with the stream. Please let me know in the chat if the audio is good, the video is good, and if there's any issue then let me know. If anything's wrong and if everything is fine, and then we'll slowly get started with the stream. Yeah, so I'll wait for a couple of some time, and then we'll get started. Put it in the chat if everything is fine and you can hear the audio. Cool. Yeah, so what I have been thinking about quantum computing since some time now. So the first I heard about quantum computing was back in 2018, I think, when there's this contest on Code Forces, which was hosted by Microsoft, and they wanted people to use their Q# language, and I thought, this is something interesting that they are trying to get algorithmic and competitive programmers into learning Q#. So yeah, so I think so that's how I heard about it, but never really got started with it, never really looked into it. So now I thought it was a good time to get started with quantum computing. So yeah, so I did try to, I just started looking into quantum computing last week, not much time I have given to it, but everything around it looks so complex. Like it was not easy. It seemed like a lot of physics, a lot of maths, to be honest, since obviously it's built upon quantum physics and quantum mechanics, so there has to be a lot of maths, a lot of algebra. I would say there's a lot of matrices, lot of linear algebra, discrete maths. You'd see a lot of eigenvectors, eigenvalues, all these terms floating around. So I figured it's not directly straightforward as I thought it would be. Like I thought I would get started with it more and could get into programming straight away, but it had a lot of theory to it. It had a lot of learning and a learning curve to it. So I decided why not try the other way around. So let's start by trying to get coding first, and then we could move on to seeing learning the basic mathematics behind it. It's not a very usual approach, I think, maybe not correct, but it has what worked for me in the past. So I thought why not try this. So I figured let's start with programming, and then while learning the programming we could look at the basics of theory and everything that's there. So Q# is a language that is used that is for quantum programming, and it is built by Microsoft, and It is an open source. I think it is open source and not sure, but there's other also programming called Qiskit, which is developed by IBM. It's an open source. That's definitely open source. So, but for now we'll be using Q Sharp. I started with Q Sharp because it was part of the challenge from Code Forces, and today we'll try to set up an environment and do the smallest tutorial for Q Sharp, and then while doing it we'll learn some of the basics of quantum computing, like superposition, entanglement, qubits, and everything, all the basic stuffs that is involved in quantum computing. Great. So let me see if everything is fine, and then we can get started. I see there are some people tuning in, so do put out in the chat if everything is fine. I'd like to know if the audio and everything is clear. If you're here, put it in the chat. That would be great. Thanks folks for turning up. Really looking forward to a good stream tonight. Yeah, so we'll be using VS Code today. We have Q Sharp that will set up in VS Code. We'll install it. I'm on Ubuntu in Linux. This should be more or less common to all kinds of Linux versions, and we'll go in a pace that I hope everybody will be able to follow if you are trying to do it live. Great. Thanks folks. Yeah, all good. Great. So let's get started. Let me so I'll start with the browser. So I have this. This is a quantum computing tutorials course which is given by Microsoft. It says it's a 4 hour 50 minutes course, but we'll try to wrap it up in around 30 to 40 minutes hopefully. So I'll put the link for this in the chat, and then we'll try to install Q Sharp SDK and then do a bit of programming in it and learn the basics, right? So let me put this in the chat so that everybody can follow along. This is the setup program setup tutorial to set up the Q Sharp for a Visual Studio Code. We'll come to this while we are following the tutorial. So I hope you are all able to get to the link and then start following it together with me. Great. So let's start with the introduction. So there's some introduction that it will initialize us to the world of quantum computing, introduce us to QDK, and how we are able to run quantum programs locally. So it's basically one thing to understand here that is very important, is that quantum computers are actually a hardware that runs quantum programs. Since our computers are classical computers, so we are not actually running quantum the program in a quantum way, but rather we are trying to simulate it. So our computer behaves as a simulator which represents a quantum computer, right? So our hardware is not a quantum hardware, but it will run as a simulation of a quantum hardware. We can get quantum hardware from Azure or from some other places, but we'll be running quantum programs in simulation with in a classical computers, that is ours, right? So let's get started with installing QDK for VS Code. So it says that you can skip. So we need to open VS Code, and then it says we need to install something called Microsoft Quantum Development Kit. But the problem with directly installing is that we need some other things to install here. So they said that we need something called .NET Core. So .NET Core is pretty important. So for that, we'll follow this tutorial, which is not directly linked from there. So this basically helps us set up Microsoft Quantum Development Kit in our computer. So I'll put the link for this in the chat. Let me put this. So so what we'll do is, this gives us some brief. We can skip all this. So we have this support for all kinds of operating systems from Linux, Mac, Windows. So I have figured that since I'm on Linux, we'll mostly follow the Linux installation, and we'll go to the Q Sharp standalone installation. Let's click on that. So one thing that is important here is that there's a prerequisite for all environments. So it says that you need .NET Core SDK 3.1. So this is pretty important. While setting up, I have actually skipped this, but it turns out it does not run without this. So we need to install this. So I'll tell you how to install this. So you see there would be two options over here when you come here. So there will be a .NET and .NET Core. So we can just install .NET Core here. We can click on this and it will take me to Linux package managers. If you're on Windows or if you're on Mac, it will take you to your operating system's download page. So it should be all right. So here I am on Ubuntu. So let's click on Ubuntu. So you can choose your version here. I am on Ubuntu 18.04. Let's click on that. Let's see where it takes me. Yeah, so it takes me here. So I have to run this two commands. So you can just copy paste these two commands. I have already run it, so I'll not be running it again, but you can simply copy paste this and run it on your terminal. It should work fine. And then we have to run these commands to install the .NET Core SDK. Now one thing to note here is that the .NET SDK here is 5.0 in the in this document, but 5.0 I was not able to run it with 5.0, so we need to actually use 3.1. So as in the document you can see here, it says that we need SDK 3.1. It says or later, but I was not able to run it with 5.0, so you can just replace the 5.0 with 3.1. So you can run these commands, apt get update, which will update your repository information, then add this install transport https, then we need to install the .NET SDK 3.1. so make sure you use 3.1 and not 5.0. okay, so let's see, after this is done, this shouldn't take much time, should be done depending on internet speed, it should take about 5 minutes. Then we need to install the runtime. So you need to install say similarly here you can just copy paste, but instead of 5.1 you need to do 3.1. So you have to install the ASP.NET Core runtime for 3.1. So once this is done, this both shouldn't take more than 2-3 minutes. It should be done quite fast, and then we are ready to actually run Q-Sharp on your machine. So I'll wait for a couple of minutes so that if you are following this, you can run this. Let me know in the chat once you are done, and then we'll move forward. Let me see the chat. Hi everyone, thanks for joining in. We have Dheeraj. Hi Dheeraj. We have Saksham. Hi Rishi, thanks for telling me. Hi Sylvia. So we have some people, thanks for joining. So I hope you're able to follow. So those who are joining us now, so we are trying to install SDK, .NET Core SDK, which is a prerequisite to install Q-Sharp on our machines. I'll also share the link to download .NET SDK in case you are not able to get it. Yeah, so it's in the chat. So you can download the .NET SDK by going into the link that I have mentioned in the chat. Click on the install .NET Core. Then a new tab will open where you will get different operating systems. You can choose your operating systems like Ubuntu, Debian, Fedora, Red Hat, anything, and then just follow the instructions given here. Make sure to install .NET SDK 3.1 and not .NET SDK 5.0, which is given in the text. So you should install 3.1. I'll just mention that install 3.1 in the chat at non 5.0. Yeah, so just for anyone who is joining us late. Yeah, so that's great. Yeah, so I hope everyone is able to follow. So I'll just quickly tell what we'll be doing today. So after this is done, we'll run VS Code, and in VS Code first we'll start with a hello world program, which is like the basics of everything, of every programming language in the world. I love that how every programming language, whatever it is, has a basic hello world code, and you can get almost anything, understand a lot of integrities or a lot of basic ideas about the programming language, just how the hello world code is written. So yeah, so once you are done, so we'll move on a bit. yeah, so I was sorry, I diverted. So I was saying we'll do the hello world code, and then after doing the hello world code, we'll do one tutorial for getting started, from the getting started tutorial, which will help us to generate random numbers from in a quantumic way. So we'll also see how this is different from the way we generate in our classical computers. Yeah. So after you have the prerequisite of installing SDK 3.1, so yeah, so we have, I hope everyone already has VS Code installed. So VS Code you can download from here if you don't already have. Let me just put this also in the chat. Yeah, so I hope everybody has VS Code, and once you have VS Code and you have the .NET Core setup, we need to install QDK for VS Code. So for this we need to click on this link. If you are following this tutorial, I'll put the link for this in the chat as well. So once we have the VS Code and .NET Core installed, we need to open VS Code. I'll show you how we can do this. So this basically helps us install the Quantum Development Kit for Visual Studio, which is developed, both are developed by Microsoft. So let me open my VS Code so that you can check how we can do. Let me see. Yeah. To let me know if you can see both my VS Code and my browser, right? Yeah. So let's follow what's given in the what's given here. So basically what you have to do is you need to copy this. So you can just copy it this way. This is a command that will help us install the, so it will help us install the Quantum Development Kit, and you need to press Control E, I think. Yeah, so Control P or Control Shift P. Yeah, it's Control P. It says to press Control P. So once you press Control P, you will see a bar open like this where you can just paste the thing you want, and then it says press enter to install the extension. I already have it installed, but let's see. I'll try to run it again and see what happens. A good test. It should already show that I have it installed, but let's see what happens. Okay, it's saying it's installing. Okay. Okay, let's see what happens. So if you have .NET Core properly installed, it should install successfully, but if not, it may throw some error. Let me know if you're facing some issues, then we'll check it out. So it says it's installed. So we have the .NET Core SDK extension installed. Now let's come back to our tutorial. So we have followed step 1, followed step 2. Now to configure for Visual Studio, no, we are not doing this. No, we are not doing this. Or we are not doing this either. Yeah, so let's get started with developing with Q#. So we have got the .NET SDK setup, we have got Q# installed, we have got Q# SDK set up for Visual Studio Code. So now we are ready to start working on our project. So for that you need to click on View, and then you need to click on Command Palette and select Q# Create New Project. Just this one other step, I think it's missing here. Okay, anyways, I think there's this one other step where you need to set up project templates. Let me just make sure that we are doing it correctly. Yeah, so this is the part we had missed. It's not there in the other tutorial, but it's here. So we need to install some project templates. So if you install project templates, then it helps us do things quickly. So what we'll do is we'll install, you need to click on View and click on Command Palette and then enter Q# install project templates. So this will install the project templates for you. So you need to go to View, click on Command Palette and just run this command here, Q# install this one, and then if you press enter, it will just activate the extensions. So yeah, so that should be good. And once you are done with that, you have to create a new project. So we'll click on View, Command Palette, Q Sharp, create new project. View, Command Palette, Q Sharp, create new project. Let's see what happens. Ah, nothing happened. We should be getting some kind of pop-up. Ah, yeah, we got this. You get this pop-up here which says a standalone controlled application, quantum library, or unit testing project. So this does takes a minute or two to load, so you might have to wait for a couple of some time to get it. So you click on standard console applications, you get this. So let me just create something in my here. Let me just create a project here. Yeah, so I'll create project. No, just create a folder. Why is this not okay, I have to mention a name. Okay, let's say quantum, and then let's click on create project. Yeah, so you get this pop-up at your bottom right, if you can see, and then you can click on it, and then when you click on it, the VS Code will open the project for you, and then you can see different two programs on the right hand side. So one will be quantum.csproj and one will be quantum.qs. You will see two programs, and then the QS, the main program is the program.qs, which is the quantum C sharp Q sharp project, Q sharp code. You can see that it already has some code which is written in hello quantum world. So I'll be trying to explain what each and everything means in this particular piece of code. But before we are trying to do this, let's first try to run it. So to run it, what you have to do is, let's see, it says, so we need to run something called .NET run. So we need to do something called .NET run, and then if you do .NET run, this should be able to run. So how can you either run it directly from your terminal, or you can open the inbuilt terminal in VS Code. So we'll just try to run .NET run and see what happens. So ideally what it will do, it will compile the project, and then it should compile the folder, and then it should try to print it should print quantum hello world. Hello quantum world, sorry, my bad. It does take some time for the first compilation. It takes some few seconds to compile, but I have seen that if you run it 2-3 more times repeatedly, it does get quicker. So till it compiles, let me see the chat. Pratyush says I joined late. Hi Pratyush, thanks for joining. You can just start, move the stream back, and then you'll be able to view everything that's going on. Yeah. So yeah, so it shows a hello quantum world, and then so this is basically it's showing what is printed here. So I'll just quickly go through the code here, and then we can move to the next bit of tutorial. The first thing is namespace. So namespace is basically a concept that comes from C# and Java. So it basically defines what this file contains. So if I am to import this file from some other program or some other piece of code, I'd be using the namespace as quantum. I'd be telling that quantum, import quantum. Like if you have to treat it as equivalent to something like Python or something, it will be like import quantum. So these are some other namespaces and some inbuilt packages that they're using. This is similar to if we are to say include IOStream in C#, then this has something similar to that. So I think the Canon namespace contains this message, or probably intrinsic, I'm not sure. So and then it prints this. So next is entry point. So you must have noticed that there is no main in this code. So similarly, if we see programs like C Sharp, C++, Java, they'll have something of a main function. So here there is no main function. So we just say entry point, and then the function that has the entry point above it is the function that runs first. And this is obviously the say hello, and then this is something, the message. So message is similar to printf or print, and then it just prints it. Unit is the return type of the function. So unit can be compared to void in other languages. And operation is something that we'll discuss a bit later. It is similar to function, but Q# allows us both operation and function. So operation comes from the is specific to quantum computing in the sense that some functions can be non-deterministic depending on the quantum state. So we'll see why this is used when we move ahead and learn the basics of quantum computing. So great. So congratulations everybody. You have been able to run your first Q# program. So tell me about, if you have any issues in the chat, and if you have been able to run it successfully. So let's move on. Yeah, so in this unit of the code, it tells us about the parts of the code, some of which I have already covered. But one of the very important thing that is here, I think, is what are qubits and superpositions. So this, I think, is the fundamental characteristics of quantum computing. So just to compare it, like in classical computers, we have bits, right? So if somebody asks what is the fundamental part of classical computers, so you'd say bits, 0 and 1, right? So qubits can be considered the fundamentals of quantum computing, and qubits are the equivalent of bits in quantum world. So we'll have to understand what qubits are. So basically here it says the quantum bit is the basic unit of quantum information. So yeah, so what I'll say is I'll use a notepad a bit later to describe some maths about it, but it's not very complex. We'll try to learn the basics. So basically a bit can be 0 or 1, right? But a qubit or a quantum bit is actually a combination of both 0 and 1, right? So what I'll say is that if you move to the quantum world, we can say, and if we look at electrons or some photons or things like this, we can say that these, we don't know in which states do these things exist. So like we are not sure. So when I say a qubit, like if it's a bit, I know that it's either 0 or 1. But if I say it's a qubit, I don't know if it's a 0 or 1. I will never know, like unless and until I check which state it is in which case it will be either 0 or 1. So it's basically, it says that a qubit can be both 0 and 1 until we check it, right? So it can, so there is a probability that it is 0 and there is a probability that it is 1. So but we don't know which one it is. But when we check what is the value of the qubit, then it will be 0 with a probability of alpha, and it will be 1 with a probability of beta. So let me just open a notepad, let's say whiteboard, right? It says whiteboard. So let me just check if there's a good whiteboard online. Let me make this screen bigger, since we won't be, we'll try to be, oh, it's it's asking me to buy whiteboards. Nice. This is not so simple. I don't want to sign up. Let's try this. Yeah, I have actually used this. This is pretty straightforward, I think. Okay, so till it loads, yeah, it loads. I actually wanted to, yeah, let's start drawing. So we have a qubit. So qubit can be both 0 and 1. So 0 qubit is called Keto 0. I think it's represented like this. And 1 qubit is called Keto 1. And then, sorry, on this, it is represented something like this. Okay. So if I say that I have a qubit, and let's say I represent the qubit with, let's say, phi, then phi is equals to alpha of keto 0 and beta of ket 1, right? So what I mean is, if phi is a qubit, I don't know what phi is, the value of phi is, and it can be either 0 or it can be 1, but it will be 0 with a probability of alpha and it will be 1 with a probability of beta. Okay, right? So, and when I'll check the value of phi, it will be 0 or 1. So it moves from, so it's, we say that it exists in superposition and it can move to a particular value only when it is checked. So we can say that a qubit is actually holding two values, that is the value of alpha and the value of beta. So this is in contrast with a classical bit, whereas a classical bit can only be 0 or 1. So classical bit can only be 0 or 1, so at one time. So let's say I have two bits, so I'll have two bits. So two bits can be 0 0 0 1 0 0, let's say 0 0, weird 0 0 1 1 0 or 1 1. So to know the value of two bits, I just need two values. I need two values to get the value of two bits. But since one qubit has two values, alpha and beta, let's say if I have another qubit, so that will have another alpha and beta. So basically two qubits will be holding four values, like alpha beta for one, alpha beta for other, and then its combination. So there will be four values for four possibilities, four values. So basically two qubits will be holding four. Similarly, for three bits, three classical bits, I'll have only three values, 0 0 0 or whatever the following is, and I need only three values. But for three qubits it will be 8. So if I have n qubits, so a machine, if it has n qubits, so it is able to store and compute information of 2 raised to the power n classical bits. So that is where the power of quantum computing comes, because it is able to represent, its fundamental value is able to represent in an exponential form of the classical computers. So therefore these are very therefore this allows us to run computation calculations, and this is where the power of quantum computers come. So yeah, so this is the very a basic fundamental thing, fundamental part of qubits. So there's something other called entanglement, but we'll probably not go into that right now, and then we'll probably cover it later. So let me quickly see the chat in between. Pitisha is one note, is Microsoft Whiteboard. Oh yeah, thanks for the suggestions. I'll probably keep it in mind. Next time I'll make sure to use those. Yeah. So right now, let's just move forward. We have covered libraries. Yeah. So let's come to operations. Now, what is an operation? So as we had seen in our code, that there is something called an operations, like we had functions and which were like functions, but the major difference is a function can be similar to a normal function that we have in other languages. That is, it is deterministic in nature. That is, whenever I call the function, the value returned or value computed by the function will always be same. But the difference in operation is that, let's say, a operation uses something called it uses something that is, you say, non-deterministic, I would say, because let's say if it's using some qubit, or if it's modifying the state of a qubit, we would not know what it will return or what will happen on every call. So it will be different every time, not every time, but it will be different, and it is not always the same, because there is the use of quantum libraries or quantum functions or anything that is related to qubits. So that is why its value won't be exactly deterministic as compared to classical functions. So that is where operations are used. So operations you can use if you are using anything that has quantum operations or quantum values. So just a simple example, if I have a operation and I use a qubit in that, so 50% of the time it will be either 0 and 50% of the time it will be either 1. So we are never sure what the value will be. So that is where operations differ from functions. Rest everything about operations are same. So yeah, this is something. So yeah, this is important. So we'll be using this. So this is how we allocate qubits. So qubits, we have to use something like using q equals to qubit, and then it will create a qubit for us. So yeah, so now let's start with the final stretch of today's program. So we'll start with creating a random bit generator. So one thing to know here is that how this is different from a classical random bit generator. So most of us would already know that classical computers, if I write a program in C and I say rand, and if I call rand multiple times, it is called a pseudo random generator. In fact, in C, if you just to write rand and run it multiple times, more often than not, it will just predict the same random number, which is not exactly random. So for that, we have to give it a seed, a times a seed value, which is usually the time, which is usually the system time. If you remember, you must have done something like srand with the time. So basically it gives it the random seed every time. So these are actually pseudo random generators. So these are random generators, but we call them pseudo random generators because they depend on the seed value that I give them, and they are not essentially random. It's not it depends on the current time that it is of the system, and then it uses some sequence and some algorithm or whatever to generate the random number. So basically, if you can manipulate the seed value, you will be able to manipulate what random numbers are actually generated. So it's not inherently randomized in true form. So that's why those are called pseudo random generators. But the good thing about quantum computers or quantum random generator is that because the behavior of quantum qubit or the behavior of quantum systems are inherently random, so we can say that the probability or the behavior of the random numbers generated by a quantum system would be more random than something that is defined by a seed value, because there is no concept of seed value in random number generation in quantum computing, and therefore the random numbers generated by quantum number will be more randomized, because the fundamental thing of a random system is of a quantum system is based on random behavior. So how can we generate the random numbers? So one logic that they have used in this particular tutorial, which we will be following, is that any number that is that any decimal number is actually can be written as a sequence of binary digits, right? So if I have a number, let's say 8, it's essentially what, 111, no sorry, 100. So 8 will be 100. So it's basically it's 1000, sorry, 130. 7 is 111, so it's basically 3 bits. So every number can be written by 0 or 1. So that's what they are saying, that every number is written by 0 and 1. So we'll generate a sequence of zeros and 1, and those zeros, the generation of those zeros and 1 will be random in nature. So since those zeros and 1 will be random in nature, when I accumulate them into one number, that will be a random number. So in this case, let's say they generated 0 1 1 0 in a random fashion, and this number turns out to be 6. So therefore we have got 6 as a random number by generating 4 binary numbers. Now how do we generate these binary numbers? If we fall back to the fundamental thing of quantum number, it's qubits, right? So qubits can be 0 or 1 in a random manner. So we don't know it will be what. So we try to generate a qubit and then look at the value of the qubit, and then we see what is the we see the value, and then we can just combine. Since the value of the qubit would be random, so we finally get a random number when we combine them. So we'll start with this. So let's see how we can do this. So let me open the code view. Yeah, cool. Give me one moment. Yeah. So let's create a new Q sharp project. Do you want to create a new Q sharp? Let's create a new Q sharp. Let's go to command palette, create new project, standalone. Where did I create quantum? Let's create a folder. Let's say random. Let's name it as random number generator. Create, open new project. So we can remove most of this code. We will not need this. You can remove. Let's keep this. We'll need this. So let's see how they are saying us to code. So they are saying blah blah blah. It's the same. So we'll need something called measurement. I'll tell you why we need this measurement. So let's see measurement. We don't know this, we don't require this. Yeah, so we have removed the function. So let's start coding. So first let's define a random bit generator. So let's have operation generate a random bit. It should return an integer. We could return it as 0 or 1. They are using as a result. So result is basically a Q sharp data type which is similar to a string. So the idea is that if I return it as integer, I'll again need to convert it to a string so that I can have a binary form. Or you could return it as an integer and multiply it as 2. That is also one way to go. But for the sake of simplicity, let's just follow what's in the tutorial here and try to understand. Yeah. So let's start with this. So we have generate random bit. So it says entry point, but we'll not use entry point here. We'll have a separate main function which we'll call this. So yeah. So let's use while q equals to qubit. So while q, we have while q equals to qubit. Oh, it's showing error. Let's see. Why is it error? Okay. It's just showing error because I'm not returning anything yet. Very leaky. Okay, cool. So we have this, and then we'll do some HQ. So HQ is basically, I'll tell you what HQ does, and then we'll need to return m reset return ZQ. Great. So now I have not run this program before, so it's highly possible that things go wrong. But let's see. Let's see, it's throwing an error. So let's see what the error is. While loops cannot be used in operation loops if in operations if possible use or repeat while. Okay, but it says not all code paths are returned. This is weird. Why is there code not throwing an error if ours is, you know? So let's try putting entry point. So maybe it's a bug in their tutorial itself. Great. If you can, if you guys are trying and if you are not facing this issue, then do let me know. Then it's probably something incorrect with my system itself. But anyways, let's see, we'll figure it out, and then let's move ahead. So while we are doing while q equals to qubit, so this is saying that we are basically creating a qubit and we are putting it to q and then h. So h basically what it does, it's basically I think operation called Hadamard transformation. Yeah, so it's basically it puts the qubit into superposition. So we have a qubit and then it like randomizes the qubit, and then basically it says that you have 0 and 1 value. It basically puts it into superposition, that is we don't know what value it will be. And now once it is there, it has a 50% chance of being, let's say, 0 or 1. And then when we call m reset z, so it basically we're trying to look what is the value of the qubit and then like trying to measure it, and then we'll get a value of 0 and 1. this will be a randomized process, and this is how we are getting a random value, right? So m reset z will allow us to look into the qubit and get its value. So yeah, so it's still throwing in error, so we'll figure out what the error is when we try to compile it. So that's what I usually do. Let's ignore it for now, and then let's move ahead. It's trying to run the program, and then it should return the value. Okay, let's try to run the program. But it should not run for us, remember, because it's throwing an error. But let's see what happens. Let's see. Yeah, it's throwing the same errors that VS Code is showing us. Let's try to copy paste from here and see if there is any typing issue in our code, which I don't think there is, but just for the sake of. Oh, I had some typing errors, it seemed. Let's see what the issue is. Oh. Okay, so there is a space issue here. I don't think there's any other issue, but that should not be an issue. If you guys can help me figure out what the issue is, that would be really great. But let me try to figure it out what the issue is. I don't see an issue here. Okay, this is not while. Sorry, it will be using. My bad. Great. So we have the code now. Let's try to run it. Sometimes the issue is in front of your eyes and you're not able to see what the issue is. Absolutely, it's really surprising. I hope you folks are able to read the code. So let me know if you are not able to read the code. If the font is small, I'll try to zoom in. Great. So this will compile, it will take some time. Let's move on. So it says yeah, so there's this parameter you can do no build, so this will quicken the process because we don't will not compile it again and again, so it will just directly run it, so it will be faster. Yeah, so it says 1, do you see? So basically it returned us 1, so now let's run it again. So this time it should be faster than before. It says 0. If I run it again, it can show any random value. It can be 0 or 1. So this gives us a value. So this is how we are generating a random bit from a qubit. So basically a qubit is the fundamental unit, and we are trying to get the randomized value. So now let's move on. So these are some things we are doing. Let's not read much theory. We'll try to figure out on our own. Yeah. So now what they're trying to do is we can remove this since this will not exactly be our entry point. Let's try to write most of the next code on our own. So we have this randomized bit. Now we'll have another function which gets this random bit and then puts it in a string and then converts that string into a value. Into a number, right? So we'll have another operation, let's say generate a random number. Let's say generate random number. It will return an integer. We can put this as our entry at entry point. So we need to return an integer. Let's think. Yeah, so basically what we can do is, let's say we always need to know how big of a number we need. I think it's there in the tutorial as well. So basically you can see that they have this max int, right? So they're passing it as a maximum value. So max int, you can just say that the number generated by this will be lower than the random number that is generated by this will be lower than this. Okay, so we have this. So let's define our own maximum value. So I thought it's int, right? They must have defined it somewhere. Okay, they're just using let. So let is data type less data type. So let's also define our own max 50 here. Let's say 50. So now what we need to do is we need to we need to get how many bits this has. So for this there is a function in Q sharp which is called bit size I. So bit size I is a function that is called that basically gives me how many numbers, how many bits that number has. So let's store that. Let's see how they have written this code. It's very difficult since I don't know which yeah, so they have got this mutable output. So basically mutable output is the answer. What if I just have it as let? I don't know, I'll try to use less fancy code that they have used. So basically mutable I think is it's something that can change. They must have defined it somewhere. So mutable are basically numbers that can change. So it says a mutable variable is one that can change during computation. So I think how is it different from let? So it should be let, similar to let. But anyways, so let's put it as let and then see what happens. So we have a repeat while loop. So while loop is basically via a repeat. This is a do while loop. So here I can say while output is less than max, till then this will repeat, and then we can finally return output. Great. Great. So we have this. Now let's try to prepare the code mutable bits. So here I am here also let's try to use let and then see what happens, right, instead of mutable. So mutable is similar to let I think, but I'm not too sure. I have not looked into what mutable means, but let's just use let for now, something that we know. Now next we have for idx bits in one dot bits bit size max. Okay, got it, call. So now we'll iterate for every random bit, and then we can see we try to generate the random bit. So set bits plus equal to generate random bit, and then we can set output equals to result array int. So result array int is basically it's a built-in function that just converts the string of bits, binary numbers, into a integer. So it's throwing up some errors. Let's see what the error is. Repeat. Okay, so sorry. So this is not while I am being very used to the code that I have written in my life till now. So it's throwing some errors here. Bits size I is no identifier. So I think there is a namespace that we have to include So yeah, so there's this math and convert. So let's include these namespaces. So these have this bit size I function. Yeah, so that's gone. So yeah, okay. And immutable identifier cannot be modified. Okay, so basically let in Q sharp is immutable. So even though if we compare it to languages like JavaScript where let is a mutable, let is a variable that you can change, but it seems in this we cannot change. It has to be specifically maintained as mutable. it gets treated like, I would say, const in classical language. So I'll have to look into, we should look into what exactly it means and how it is different from a normal const. I'm pretty sure there is a logical reason for it. So let's put in some max value of, let's say, 50, and then let's run and see what happens. Okay, what, they're writing a lot of code. Okay, so they just wrote the main function. We can skip this. Okay, this is easy. So we'll not look into Azure Quantum. Let's try to generate the numbers. The numbers are yeah, so we got 10. So we got a number. Let's put some message over here, like they have put sorry, message generating a random number less than, can we put max here? Does this work? So okay, so should be able to use dollar and just like in JavaScript. So I hope everyone is able to follow, and then if you have any issues, put it in the chat and we'll try to look into what issues you are facing. So let's wait a couple of seconds for it to generate a number. So there's a bonus exercise. You can see the bonus exercise says that you need to generate a number which is greater than some min value. I hope everyone can try that and put it in the until loop. That is not algorithmically challenging, but yeah. So this is how we generate a random number. We did a bit of coding in Q#, and one thing that I would like to mention here, we should get back to theory a bit. Let's keep this. Yeah, so one thing in theory that I would like to mention is, when I say a qubit, so this is very important. So qubit, that is ket 0, let's say ket 0, this basically is a vector, that is a linear vector which is represented as 0 and 1. So this is the ket 0, and when I say 1, this is 1 0. Yeah, so these are the two values that we have. Okay, cool. Yeah, so these are the two values that we have, and so this is very important, since this is the fundamental part of quantum. So these are the two linear vectors, and everything that is built in this universe is based on these two matrices. So the important thing is that when I will I forgot what I was trying to say. Sorry for that. So when I say alpha ket 0 plus beta ket 1, I'm basically meaning that alpha is multiplied to this and beta is multiplied to this. And alpha and beta are probabilities that the qubit exists in 0th state and or exists as 0 or exists as 1. So one thing that I have to mention is that since these are probabilities, they have to be 1 or something like this. I can put. So this has to be 1, right? So these are some of the fundamental things of using qubits and using quantum computing. I hope you are able to go through this exercise. If you're not able to do it now, I hope you're able to do it next whenever you get time. Try to do the bonus part, and we can see that there are other exercises over here. If I go to quantum computing foundations in this thing, there are other exercises. Not here, sorry. Tutorials. There are other tutorials here of quantum number generator that we did now. There is something called Grover's search. There is something called qubit level programming, and a lot of others. I'm hoping that we'd be able to take on some of the coding questions from the Q-Sharp contests on Code Forces. I'll just show it now so that you know what I'm talking about, and then we'll probably do a stream in the future where we do the Code Forces Q-Sharp contest. Oh, question 3, sorry about that. Yeah, so I'm talking about the Microsoft Q-Sharp coding contest. This is the editorial, this is the second edition. The summer 2018 is the first edition, so this is something. And there's also a warm-up contest. If you see, there's a warm-up contest they have mentioned here. Let me see if there is a link here. Run Q-Sharp. Yeah, we'll access the problems here. So you can try these warm-up questions. The warm-up questions are pretty easy. Not pretty easy, I would say. They are okay. This looks a bit daunting, but these are actually very easy. So this first question is basically very simple, and we just have to use just make 3 qubits. So and then we have n qubits, and we just have to put them into superpositions. So now we have already put them into superpositions in our code once, like saying by doing using a q. So you just have to generate all the superpositions that are possible. So yeah, sorry, using q equals to qubit and then h of q, so that puts it in superposition. So you can try this, and then we hope that we can have a stream on this as well later. Yeah, I think that's all for today. You can check out this tutorial. It's in the chat, link in the chat, and if you're not able to follow it now, you can follow it. You can re-watch the stream. It will be public. Thank you everyone for joining in. I hope you are able to learn something, and you are able to get a vague idea of what the world of quantum programming is and how it's different from the classical programming. And we didn't talk about in detail about what is its impact and how it's doing leaps and bounds over classical programming, but it's nice that we just got started with programming directly into it, and then it will help us understand the theory a bit easier as compared to just understanding the theory and not doing the programming part of it. So yeah, thanks everyone for joining in. I'll quickly look at the chat if there's anything. Oh, a lot of people are catching up. Thanks folks for joining in. Saksham, I hope we can do stream soon on cracking that. We'll have you as our guests. Thank you everyone for joining in. I'll sign out for today. Really lovely to have you all. I'll just play Army's track at the end once again, and then I'll stop the stream. Thank you for joining everyone.
शातिर ज़बान ये कातिल कलम मेरी हासिल किया जो भी काबिल मेरे, ना दिल किया कभी छोड़ दूं इन्हें मैं और दूं, अभी तो बादल घिरे, बारिश भी होगी झूमेगा सावन भी, गा दूंगा शब्दों में साहिल तेरे, हालातों की गर्मी ना मापी खा पी के सो जाऊं, सच्ची मेरा दिल करे कि मैं गाऊं ही ना, पर ये कलम भी ढीठ तो कैसे रुकूं, फाड़ दूं कागज तो तेज दिमाग ये लिखूं ना सीधा मैं आके बकूं, मैं ये माइक पे साइड में रखी ये काम तो वाइब में सोता मैं कैसे थकूं, सीधे है काम ये सीधी है बात और सीधी है पीठ तो कैसे झुकूं, मुझे आता नहीं मेरा नाता नहीं, नेगेटिविटी से दूर हूं बैठा कहीं सच रहता जब आप ने झूठ का साथ में तेरे इलाके का नेता नहीं, यहाँ करे सब अपनी तो क्यों चलूं पीछे मैं, दुनिया तो ऐसे ही घूरेगी, सोचते घर वाले कमा लूं पैसा पर करने तो सपने हैं पूरे भी, करना तो है ही मैं करके रहूंगा, मैं करता था क्या मुझको ध्यान नहीं।
Bye everyone.